Well, I'm already supposed to start. Sorry about that. All right, my name is Michael Nugent, and I recently converted a report that I did for school into this presentation, which wasn't as easy as I thought it was. I don't like PowerPoint or Impress in this case. What I want to address is the technology standards as they appeared predominantly in the Ohio Education's Technology Standards documentation. But what I want to focus on mostly is how and why have these technology standards failed to address computer science. And by fail, I don't mean not attempted. I mean, I mean failed in terms of not attempted, not in terms of they tried but failed. There's things that are just missing. And then how and why should the technology standards be improved? Now, this is what I want to focus on predominantly. The standards, education standards, are produced by each state, but usually closely reflect the national standards. As far as I can tell, without doing a word-by-word comparison, they're almost identical. They're long documents, written to be general, yet encompassing providing a guideline for a curriculum that teachers would use in their classes. Whole portions of it, it's like the entire thing is rewritten 3 times. Whole portions address it from a different perspective, from the teacher's perspective, from the standards perspective itself, and also from the student's perspective. And the intent there is that teachers then will be able to get a better perception of what they're supposed to do. However, in all this, the teachers are able to exercise some creative latitude. The technology standards specifically, the ones that I wanted to address, are produced by an outfit called ISTE, which is the Standards in Technology and Education Department, and that's the national one. And that template is used also in the national. They use it in the state standards as well. The benchmarks for technology are not as honed as the ones for math or science or social studies, for that matter. The contributors, though, seem aware of the lack of refinement because they meet rather often. Their minutes, the tone of their minutes for the meetings, they're different than the ones for the other areas, which are more like, what are we going to do next year to bring more attention to this? This is more like, how are we going to accomplish this? There's a few hopeful quotes in the technology standards, which is what drew me to them in the first place. Technical capabilities are important tools in preparing students for high-skill, high-knowledge jobs. This quote comes right from the technology standards, and if you've been to some of the other talks here today, there's a big concern about brain drain in Ohio, and so I certainly would agree with this. The second statement, though, the integration of technology into all content areas enhances learning and supports effective instruction. The issue here is that there's some research, substantial research, to indicate that this might not actually be the case. Trying to integrate computers into the classroom doesn't always produce the results that they'd like it to produce, the results being higher test scores, more aptitude, more interest in the subject matters. So my experience with this, in 2003, I willingly left BP rather than emigrating to Tulsa. I don't know if anyone's ever been to Tulsa before, but it's just not a very interesting place. BP is British Petroleum. It's the oil company. And this accelerated my plan to become a teacher. During this class, I was supposed to develop a lesson plan based on any of the standards. Well, I chose to explain algorithms and how we use them to third graders. Now, the research for this, the idea for this, came from some stuff that I read. Seymour Papert. Papert is a student of Piaget who was educator in Switzerland at the time, and they did a lot of research into how children think, how children learn in particular. Piaget theorized constructivism, which is that knowledge is constructed internally and then tested against reality. And we watch kids do this. They think they know something and they want to find out what this now means to them. This is an effective way for them to learn, but that isn't the way most schools teach. And so Piaget formed this school of constructionist thought, and Papert was his best student. Well, Papert believed he developed a language called Logo, used to teach very young kids, as young as 4 years old, how to program, how to put their thoughts, how to put their processes into a procedural language. So I wanted to see that in action, not Logo itself, but just I wanted to see young kids doing computer stuff. So, why is that off there? So I reviewed the technology standards, but I couldn't find any benchmarks. These standards are broken down into areas that specify how you're supposed to address certain aspects of the curriculum. For instance, the term algorithm appears only in the definition of a term in the glossary. I don't remember what that term is right now, but programming is used to describe designing web pages, which isn't really programming. And for any web designers here, what I mean by programming is that HTML, which is meant to mark up text, is not procedural or functional or algorithmic. They're more descriptive languages, CSS and XML and things like this. So it's not really a way to compose your thoughts. So I gathered from the different parts of the technology standard with great interpretive liberty. I took this one, identify machines, and describe how these machines extend human capabilities. I figured, well, what the heck? I mean, I guess algorithms are machines in a way, in an abstract way. Solve a problem using iterative discovery. I stretched this to convey debugging for the most part. I thought this was the closest thing to debugging I could find. Address the economic consequences. Well, I mean, this we could potentially do. I thought we could consider improving economic development, but potentially in the compare and contrast way that it might reduce or limit the number of unskilled jobs that were available, as most automation does, software being no different. And then the third, I took parts of the standard 7 there, and these are the benchmarks. A2 is a benchmark in B1. Understand how machines and information are used to develop useful systems. Well, it sounded good, but I really wasn't sure how I could stretch this to apply to programming. I went through a couple of the other standards, the math and science ones, trying to see if I could find anything there, and there just wasn't. So there's no guideline for teachers to teach computer science, to teach any kind of computer theory or programming or algorithms to kids. So I figured that the technology standards fail in 4 obvious ways. One is misapplication. The benchmarks are presented just because they're designed to use a computer. Sometimes this could be completely like writing a term paper. It uses a computer. Well, we're going to call that technology. You could do that with a pencil, though. Social mandates. Benchmarks emphasize mores as if technology requires the emphasis. And this I'll get into a bit later. The glamour. Technology is used to bait or heighten student interest, as if it really needed to be done that way. And then underestimation of students' abilities is one of the foremost ones. So, misapplication. Technology standards introduce application software, not underlying concepts. Technology standards, in my first draft of the paper I used card catalog as an example. I was suggesting that using a computer, learning a computer should be done in social studies. Using a computer to gather information should be done in social studies, where you can use card catalogs, but I didn't realize that most people probably haven't used a card catalog. Has anyone used a card catalog? Yeah? Oh, have they? Oh, I didn't even know. So I changed that to be something else in the term paper. There are research tools that are appropriate to social studies, and then one thing I should note, though, is that the technology standards are meant to intermingle in other courses. Like someone in social studies, like a social studies teacher, is supposed to implement the state's standards in technology also. My problem was more that I just couldn't find a place for my stuff to fit. The social studies one I just covered. Text justification by the technology standards, should be covered by technology standards, whereas word processing, which is what it currently says in the technology standards, I think should be covered in like English class. Graphics standards, they talk about using a mouse to paint a picture. I think this could be done in an art class. The social mandates kind of bothered me, mostly because of the presumptions that they made. For instance, I don't remember addressing shoplifting in school, and I was in an inner-city Catholic school where you think that might have come up. But now we're bombarded with rhetoric about IP and piracy and the rest of these things. So I don't think technology demands any more adherence to ethics than chemistry, yet the standards direct students toward an imbalanced ethical use. I'm wondering if, for instance, anyone told A.Q. Khan that his use of mathematics and science was an immoral idea. I think that just as much damage can be done using any knowledge that we have. I don't think computers are in particular bad. The perspective is usually only from the IP owner. The curriculum, as it's stated in the technology standards, warns against infringement, but it doesn't discuss the rights of the students, the ones that they should have or did have and have been taken away from us. The Mickey Mouse bill, sponsored by Sonny Bono, it's the Copyright Term Extension Act, lobbied by Walt Disney. This was to protect their asset, basically, Mickey Mouse, from expiring and going into the public domain. So now we have basically indefinite limits on copyrights. Also, there's a blurb in a thing I just read yesterday that Arthur Adams received a complaint from the lawyers for Uncle Milton Industries of trademark infringement after using the term ant farm in a comic strip. Apparently, ant farm is not a generic term. It's a trademark. So he wrote, it became clear that as long as there's dirt and ants and glass and people who will pay money to see them pressed together, there would be money to pay a lawyer. So we have issues like this that need to be addressed. Under this curriculum, students are more likely to use copyrighted work than to produce one. But I think that that should be encouraged. I think that kids should produce those works. They should copyright them to understand their rights as a copyright holder. I also think that they should open those copyrights up, though, in terms of licensing. I'd like them to be open licensed. Glamour. The computer is considered a resource for learning in a rich multimedia environment, and this goes without saying, but not only does the technology get perhaps misapplied, but it gets the glitz that it doesn't really need. Kids already like new things, and software makes computers shiny and new every day. Technology, though, has resurrected accounting, typesetting, photography, and typing lessons. Things that we haven't done in ages now have started to become popular again, like kids are balancing their checkbooks and stuff like this just because there's software that provides that, and the teacher really can't think of a better lesson, I suppose. I'm not sure. Underestimation. Paper studies and those of many of his students show that children can learn at ages as young as 4. The transition in a single grade from applying simple technologies to creating simulations without supporting concepts in lower grade, this really isn't so much a way that they underestimate. Perhaps this could be an overestimation. They're supposing that suddenly in this particular grade these kids become knowledgeable of how to do programming, but that really doesn't help because they're missing. The teacher's not instructed how they're supposed to get to that point in the first place. They first imply technology theory in the 4th grade. In the 6th grade, they suggest that they have a lesson that uses technology to organize data. In grades 7 and 8, they recommend technology to investigate data and present conclusions. And then in 8th grade, they recommend creating these simulations. Now, without some sort of underpinning, without some ability to model using computer languages, I presume they must be talking about using things like SimCity, which does require some thought and programming as well. And I'm not averse to that, but I would still love for them to be able to model their own ideas in their own way. Boolean expressions aren't mentioned until the 9th grade. And this actually came directly from the science standard. Quite a bit of the technology standard came from a section in the science standard called Science and Technology. So programming finally appears in grade 12.